This is the second and slightly shorter video about crude oil, and we're going to look at alkanes and just add to the understanding that we got from the first video. Now, just as a reminder, we said in the first video that we have a fractionating tower that separates out the parts of crude oil, and we call these fractions, and they all separate out at different temperatures. And there's a pattern in terms of the molecule size, boiling points, viscosity, and flammability as you go down the tower, and you can see all the details of that in the first video about crude oil. What I want to do today is to add onto our understanding, and we're going to start off by just revisiting a little bit. We said that most of the compounds that come from the fractionating tower are hydrocarbons. Okay, so that means that they contain the elements hydrogen and carbon only. Hydrogen and carbon only. No other element should be present. And if there is another element, then it's not a hydrocarbon. The second thing that we talked about was this is the structure, and this is what a hydrocarbon might look like. We have a central spine here of carbon atoms, and I've got a little key here to say why that's the carbon atoms, and surrounded by hydrogen atoms which are attached to each side of the carbon, and one hydrogen attached to each end. Now, let's move on to the slightly newer stuff. We can write this in a different way. We don't have to draw little circles or coloured dots. We can actually write out the symbols, and this is how it would look if we wrote out the symbols. This molecule here is exactly the same as this molecule here. I've just written it out with symbols instead of dots or coloured circles. There is yet another way which we can write this out, and that is by writing the formula. So we know hydrocarbons have hydrogen and carbon only, and so we write carbon always goes first, and hydrogen. There are no other elements, so we don't need to write anything else. And then it's just a simple case of counting up the carbon and the hydrogen. So we've got, in this example, 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 hydrogen atoms. So the formula for this hydrocarbon is C9H20. Okay, so this is two ways in which you should be able to write out what a hydrocarbon looks like, the formula and the diagram like this, and you are required to do that by the specification, and it's not that difficult, as you can see. Now, let's look at a specific example of a particular hydrocarbon that I might get from the tower. This is a container with the hydrocarbon in it. It's a gas, and let's take out one of the molecules, and there it is. So you can already write out a few things about this based on what we had on the previous page. You could probably write the formula, and you could probably do the structural diagram again with the symbols. There's a couple of new bits of information that I want to add to your knowledge that you have already. Now, the first thing is that for these hydrocarbons, I want you to remember that there are no double bonds between the atoms. Okay, so here are the atoms. In this particular kind of hydrocarbon that we get from the fractionating tower, there are no double bonds. A double bond would look like this. So here's your carbon and another carbon. Double bond would look like that, two lines instead of one. But we don't have those with these types of hydrocarbon. The other way you would describe this type of hydrocarbon is that it is saturated. So we say it's a saturated hydrocarbon, and this in fact links to this idea that it has no double bonds, and that's why we say it's saturated. It's a saturated hydrocarbon because it has no double bonds between the atoms, and these two both link to the type of hydrocarbon it is, and you may have heard this word before. This hydrocarbon is called an alkane, and that links to what we've just been saying about the fact there's no double bonds and it's saturated. Okay, now the third bit of information I want you to know is there is a general formula, and you are required to know this, CnH2n plus 2, and we're going to explore what that means in a moment. And if we were to write the formula for this, we could do what we did on the previous page, write the C and the H, count up the C's, 1, 2, 3, count up the H's, 3, 6, 7, 8, and there we have it. That's the formula for this particular hydrocarbon. It's a saturated hydrocarbon, meaning it has no double bonds, therefore we call it an alkane. This general formula we could use to work this out. Some of you may be ahead and have that already, but if not, let's look at that. Before we go any further, have a go at doing this one. Write out the general formula, sorry, not the general formula, write out the formula for this particular hydrocarbon as we have done previously. You can pause and do that now. I'm going to write it out, so after you've written it down, you can check your answer. Okay, so hopefully you got that. C10H22. Now, what has this got to do with this? Well, we call this the general formula, and it's a way of working out the formula for a hydrocarbon that has any number of carbon atoms. So for example, if I said to you, I've got a hydrocarbon and the number of carbons equals 16. Okay, now what you could do would be the slightly easier way, or an easy way, would be to draw it out. So you could draw out 16 carbons along in a line like that. You could add all the hydrogens and then you could count them up and you would have the formula. A slightly easier way would be to use the general formula, and in this case should we use a different colour? Let's use green. That N there represents the number of carbon atoms, and there's two N's in there, so it's written there, and this just represents carbon and this represents hydrogen. So for this example here where C equals 16, let's work out the formula using the general formula. So we know we've got C and H for these hydrocarbons. Now C is 16 in this example, so we're going to replace this N with 16 because we now know that C is 16. So the number of carbon atoms is 16. So if I put 16 there, okay, and for H's, well, we just again follow the formula down here. This means two N's add 2. And what is N? N is 16 in this case. So we say 2 16s plus 2. And if we work all this out, we have C16, H 32, add 2 is 34. Okay, so there's the formula for a hydrocarbon that has 16 carbon atoms in it. Now what I want you to do is to look at 4 specific alkanes. I want you to work out the formulas using the general formula CnH2n plus 2 for 4 special alkanes, and those are called, let me change back to a better colour, those are called methane, ethane, propane, and butane. Okay, and you need to know these particular names and what their structures look like. So if I tell you the number of carbon atoms for each, have a go at writing the formula, and then you can pause and check your answers. So methane, C equals 1, C equals 2 for ethane, C equals 3 for butane, and C equals 4 over here, and let's just throw another one in where the number of carbon atoms equals, I don't know, 17, just for practicing one that's got a slightly bigger number. Okay, so pause, write it out, write out what you think the formulas are, and then check your answers. I'm going to do this right now, so you have a go, and then just check your answers in a minute. Okay, so hopefully you got those answers. You could, if you wanted to, go on to draw them out, like so, but I'm not. I'll leave that to you to do. It's not a hugely difficult task. So there we have it. You should be able to describe what we mean by the word alkane. You should understand the new keywords: saturated hydrocarbon, alkane, as we said, and you should be able to use the general formula for drawing or writing the structure of these things called alkanes. I went on a bit more than I wanted to as usual, but anyway, I hope you enjoyed, and see you in the next video.